So this first question has a power of x that's a fraction, which is, I know, causes some problems when we're taking derivatives, so we know we have to take extra care while we're trying to answer these antiderivative questions. Again, the idea here is I want to find an answer, I want to find an f of x whose derivative is 20x to the 3 halves. So we ignore the s symbol and the dx symbol. Those are part of the notation. Again, we'll learn more later about why that notation is there. Right now we want to just figure out a function that has 20x to the 3 halves as its antiderivative. So we can go through the process again where we figure the 20 must be part of the issue. We know that whatever function we use should have a power that's one more than the power of this question. So in the 3 halves power, 1 more than 3 halves. Again, I can come over here, 3 halves plus 1, 5 halves. So 3 halves plus 1 is 5 halves. So I know that if I start off with the 5 halves power in f of x, then when I take the derivative, that power will be reduced by 1 and be x to the 3 halves. So using 5 halves power there will give me the x to the 3 halves power when I take the derivative. Now you may wonder why I left a space here. The reason is that if I want to leave that 20 there, like it was in the problem, then the way I can do the problem is leave the 20 alone, and then here, just think about what number needs to be here so that the derivative of this whole thing ends up being 20x to the 3 halves. And the trick is to think about what's going to happen when we compute the derivative of x to the 5 halves. The 5 halves doesn't just get reduced to 3 halves, but actually the 5 halves comes down in front. And so if we put a 2/5 here, that's the reciprocal of 5 halves. If we put 2/5 there at the beginning, then when that 5 halves comes down with the derivative rule, it'll get multiplied by 2/5 and it'll be 1 and it'll go away. So if I use this as my answer, of course, plus c, let's simplify this and then we'll check it. 20 times 2/5 is 8. So I have 8x to the 5 halves plus c. So when I check, I have f prime of x is equal to, again, I leave the 8 alone. The derivative of x to the 5 halves is 5 halves times x, and I need to reduce the 5 halves by 1, which would be 3 halves. And of course, the derivative of the plus c is just 0. The c there, remember, is not a variable. It just stands for plus any number, plus 3, plus 5, anything. So whatever would be there, whatever number's there, the derivative will be 0. If I work this out, 8 times 5 halves is 20. And so I do, in fact, have 20x to the 3 halves, just as I wanted to. So the trick is in here. The rule that's being used here is our power rule for antiderivatives. So in general, it'll look like this. If I'm trying to find an antiderivative of x to a power, then I know that I will need to have x to a power that's 1 more. So just like here, my original power was 3 halves, so I made it x to the 5 halves. And then in front of that, I always leave a gap here, because in front of that I want the reciprocal of this power. So generically, the reciprocal of something is just 1 over that. But I would think of it as the reciprocal because when you have something like x to the 5 halves, you don't want to put 1 over 5 halves out here in front of it. You want to just put the reciprocal. So the reciprocal of 5 halves is 2/5. We saw in the previous problem that the reciprocal of 3 was 1/3. And of course, there's a plus c on here as well. So this is a really good rule. It works for all powers except for one. It works for everything except -1. Because if p is -1, then in this number here you'll get a 1 over 0, and you'll know that the rule can't possibly work. So this rule works for every power except for -1. And we'll address -1 in just a second. So this question is written in a more direct way. It doesn't use the integral symbol, but it's really asking for the same thing. So an equivalent question here could have been, what is the antiderivative of e to the x plus 19 dx? So that would mean the same thing. But this is directly saying, find me something whose derivative is e to the x plus 19. So just like derivatives, we like the e to the x antiderivatives because they're easy. The antiderivative of the x is e to the x. again, because the derivative of e to the x is e to the x. Antiderivative of 19 should be 19x, and then plus any constant. And if you're not sure, then by all means check. In fact, on the exam you will always have to check for me. The derivative of e to the x is e to the x. The derivative of 19x is 19. And the derivative of c, since that just stands for a number, is just 0. So the derivative of e to the x plus 19x plus a constant is just e to the x plus 19, which is what we wanted it to be. So my answer here would be this expression. Here's another question with the same notation, but you see they've actually added a piece of information here. They're telling us more, and we'll see that that actually allows us to give a much better answer. Let's don't worry about that right now. Let's just pretend like this is exactly the same as the other question, which only had this part. So just like before, we would start off by just finding antiderivatives of each of these pieces. Antiderivative of 5x to the minus 1. Well, using the power rule that I developed, we leave the 5 alone. I would leave some space here. I would increase the power minus 2 by 1, which will make minus 1, and then multiply by the reciprocal of that. So just literally 1 over that. So that thing in parentheses will have a derivative of x to the minus 2, like it's supposed to. And I have plus 6 times, and you see I have x to the minus 1 power. Well, the minus 1 power is exactly the case from the previous problem that I said our rule would not work. If you do accidentally apply it, you'll get a 1 over 0 in your answer, and that should tip you off that something is wrong. The answer is actually much easier than that. It's actually the natural log of x. Now, one thing you'll notice, especially if we have to enter the expressions completely symbolically in these blanks, is that the correct rule is actually the log of the absolute value of x. The absolute value are these vertical bars here, and so when we get an antiderivative answer using natural log, we really ought to put the absolute value bars on it. A lot of times in application problems, the x stands for something like number of items produced. That has to be a positive number, in which case the absolute value bars really aren't necessary. But without a context, we really should put the absolute value bars on the x inside the natural log when we're doing an antiderivative. Antiderivative of minus 1 is just minus x, and we always have a plus c, plus any number at all on the end. That c is called the constant of integration because, well, we haven't talked about why it's called integration yet, but that'll be the next section. It's a constant that ends up on antiderivative problems. Now, that's not actually the right answer here because there's more to it. They've given us a little more information, and so we should be able to give a little bit better answer. Before I try to do that, let me at least simplify this a little bit. I have 5 times negative 1 here, and then 6 times log of x in absolute value minus x plus c. Okay, so this is my answer. That's as good as I could do from previous problems, but they do give me one more piece of information here. They tell me that if in my expression I let x equal 1, then I should get an answer of y equals 3. So in my highlighted expression here, if I use 1 for x, so the x's are over here, so if I use 1 for x, I should get 3 for y. So using 3 for y and 1 for x, this should still be true. Well, this says that 3 is, this expression is negative 5. 6 times the log of 1, the log of 1 is 0, so that's 0 minus 1 plus c. So this is actually an equation that's very easy to solve for c. I could just add 5 and 1 to both sides, and I will get 5 and 9 equals c. So I can just solve this algebraically for c. So therefore, the complete answer here that goes in the box is that y should be negative 5 x to the minus 1. I'm just copying what I highlighted here. Plus 6 log of the absolute value of x minus x plus 9. That function will do two things. It will satisfy this derivative, and I can check it. I can take the derivative of this expression that I got from my answer and check that it is 5x to the minus 2 plus 6x to the minus 1 minus 1. I can also check this property, that when you use 1 for x, you're going to get 3 for y. So this function satisfies both of those properties. The same idea from the previous problem applies to our application problem. In an application problem, when we have a function that stands for cost or sales or revenue, we don't expect it to have a plus c in it because we expect it to be a real function, a specific function, not one of any number of functions. So in a problem like this, we're told that s prime of t has a particular formula. That's enough for us to figure out what a formula for s of t is. S of t here is monthly sales. So if you tell me the derivative is minus 20t to the 2/3, well then I know that the formula for the function is minus 20. I'll add 1 to 2/3, which will be 5/3. That means there needs to be the reciprocal of that, 3/5 out here in front, plus a constant. And I'll simplify that just a little bit so I can work with it more easily. Negative 20 times 3/5 is negative 12. So the correct formula for sales is minus 20t to the 5/3 plus c. But that's not a specific function. That could be plus 1,000,000 or plus 2. We need more information to say exactly what our sales function is. So if we look at the problem, there should be some information here about sales, and this is it right here. They say that when t equals 0, monthly sales are 1,860. So in other words, when t is 0, I should get an answer for sales of 1,860. But according to this formula, when t is 0, this formula says minus 12 times 0 to the 5/3 plus c, and 0 to the 5/3 is 0. So this is telling us that the c is 1,860. So that means that our sales formula, rather than just being this generic thing that we don't have a c for, we actually have enough information to say that our sales formula is minus 12t to the 5/3 plus 1,860. And again, it's easy to check. I can take the derivative of that and find out that this piece of information is correct. And I can put 0 in for t and see that I get 1,860, so this piece of information is correct. So that formula should do it for me with both pieces of information. Now this problem has a little bit extra going on because it doesn't just ask for that answer. That's the first part in this box. But it actually asks us, how long will the company continue to manufacture this computer, when we're told that they're going to stop when monthly sales slow down to 900 computers per month. So to find out when that happens, I've got to take my sales formula. This is telling me what my sales are in any given month, set it equal to 900, and then solve for t. Find what month that's going to happen. The algebra here is a little bit different, so I'll go ahead and do it for you. We do have this minus 12t to the 5/3, which looks a little intimidating, but all we can really do in this case is try to isolate this expression. So if I subtract 1,860 from both sides and then divide both sides by minus 12, I will have isolated the t to the 5/3 expression, and over here I'll have 80. So technically what we're going to do is take both sides of this expression and raise them to the 3/5 power, the 3/5 being the reciprocal of 5/3. So if I raise both sides to the 3/5 power, that should still be true. If this was true originally, then raising both sides to the 3/5 power should still be true, but on the left side, I end up with just t, because 5/3 times 3/5 is 1. And over on the left side, I have 13 point something something something. So about 14 months, I believe, is the answer. I don't know if they want how accurate they want that answer, but that's easy to do in a calculator.